This linked list problem looks impossible. You need the biggest twin sum between opposite nodes, but there's a super easy trick most people miss. Want full solution? Check this video.
Hi everyone and welcome back. Today we are solving the leetcode problem, maximum twin sum of a linked list. Let's start by understanding exactly what the problem is asking. We are given a linked list of size n, and n is an even number. And that means that our linked list contains an even number of nodes. For every node, there is a twin node. The first node is paired with the last node, and the second node is paired with the second last node, and also the third node is paired with a third last node, and so on and so forth. The twin sum here is the requirement is defined the sum of the node and its twin. So our goal is to find the maximum twin sum among all pairs. Let's look at an example. Suppose that we have this linked list. So the first node 5 is paired with the last node 1, and the twin sum is 5 plus 1, which is 6. And also the second node 4 is paired with the second last node, which is 2, and this gives us the twin sum of 6. So the maximum twin sum here in this example is 6 because both twin sum have the same value. So now let's think about how to solve this problem. There are multiple solutions to this problem, but I choose the one that is more readable and easy to understand. As you know, the challenge is that we are working with linked lists, and in linked list, we can move forward easily, but we cannot directly access nodes from the end. However, the twin relationship depends on accessing node from both ends of the linked list. So here is the key idea. Instead of working directly with the linked list, let's copy all the nodes value into a vector. Once the values are stored in a vector, we can gain random access. That means we can instantly access both the beginning and the end using indices. So let's walk through an example step by step. First, we will need to create a vector, an empty vector, and that will store the values of the linked list. And then we traverse the linked list from head to tail, and for every node we push values to the vector. So again, if we apply this algorithm to our example, after traversing this linked list and pushing every element into array, we will have a vector that looks like this one. And now the problem becomes much easier. Let's determine the twin pair using indices. So the first element at index 0 will be paired with the last element at index n minus 1. And also the second element at index 1 is paired with the element at index n minus 2. So in general, each element at index I is paired with element at index n, which is the size of the vector, minus I minus 1. So let's see how this translates into code. We start by creating a vector, an empty vector. Let's call it nums. Then we create a pointer called current and initialize it to head. So we now have a linked list pointer, linked node pointer called current pointing to the head node. And then we will iterate over the linked list. So while current is not null, then we need to push the current value into null. And don't forget to increment your current pointer to the next node. So at the end of this loop, the vector now will contain all the values from the linked list. Next, we need to calculate the size of the vector. So int n equal nums dot size. And we also initialize a variable called maximum sum to 0. So int max sum to 0, and this variable will store the end result or the maximum twin sum. And now we iterate from index 0 up to n divided by 2 minus 1. So for int I equals 0 and I is less than n over 2 plus I, we define a variable sum that equal nums of I, this is the first element of the twin, plus nums of n minus I minus 1. This is the second element of the twin. And then we compare that new sum to our maximum sum, and we store the new maximum sum. And simply at the end of this, after the end of this loop, we return the maximum sum. So let's run it to make sure we don't have any syntax error. Let's submit it. And here we go. Now let's analyze the complexity. We traverse the linked list once to build the vector, and this takes O of n. Then we traverse half of the vector to calculate that twin sum, and that's also take O of n time. So the total time complexity in this case is O of n. For space complexity, we are storing all the node in a vector. The vector contains n element. Therefore, the space complexity is O of n. This is a very clean and intuitive solution. There are some other solutions that optimize the space complexity by traversing half of the linked list, the second half of the linked list. But I chose this solution because it's clean and easy to understand. And that's the important observation is that once we converted the linked list into an array, finding twin sum becomes extremely easy because we can directly access elements from both ends of the vector. And that's it for this problem. If you enjoyed the explanation, make sure to like the video, subscribe to the channel, and let me know in the comments if you would like to see the optimized O of one space solution as well. Thanks for watching, and I'll see you in next video. Bye.